Okay, we have seen C++ program that have sequential execution, and the statements were executing one after the other, and there were a linear flow of control within a program. We have not seen such thing like skipping the statements or the block of the statements, or we are going to repeat the block of the statement again and again, or nothing like that. We are selecting one block out of many blocks. We are not applying any conditions like if such thing happens, then execute this block of statements and otherwise execute other block of statements. Up to now, we have very simple programs and the things were running really smoothly. But now we have to go to a little bit advanced version of the C++ program in which we are going to skip some block of the statements, applying some conditions. So in C++, we have certain conditions, we can apply certain conditions, and then on the basis of these conditions, either we have to execute that statements or we have to skip those statements. Control structures. Control structure is any statement that alters the linear flow of control of a program. C++ examples include if, else, while, for, break, continue, and return statements. Sequential execution. Statements executed in order. Transfer of control. Next statement to be executed may be other than the next one in the sequence. So usually we have the sequential execution, and the control structure is the one which alters the linear flow of control. And we have the transfer of control in which the next statement to be executed, we expect that next statement would execute, but that can be the other or the next one in the sequence. We have three control structures. First, sequence structures. Built into C++, the program executed sequentially by default. Second, selection structures. C++ has three types: if, else, and switch. Repetition structures. C++ has three types in which we have while, do while, for. So basically, in the first case, sequence structure, and this is by default, the program, the C++ program, the statements execute one after the other. And then in the second type of structures, in which are called structure, its name indicates that we have to select a certain block of statements depending on the condition. If the condition true, the statement would be executed. Otherwise, these statements can be skipped. In third type, we have the repetition structure, in which we have three types of repetition. We can use the while loops, we can use the for do while loops, and we can also use the for. All these type of loops have the same purpose. They are going to repeat certain statements within a program. If selection structure. Perform an action if condition is true. Skip the action if condition is false. If else selection structure. Perform an action if condition is true. Perform a different action if the condition is false. Switch selection structure. Perform one of many different actions depending on the value of an integer expression. So in control structures, we have, if we talk about the selection structures, if we focus on the selection structure at this point, in the selection structure 2, we have three type of versions. If selection structure, in which we are going to execute a certain block of the statement if the condition gets true. But when we come toward the second version of this selection structure, in which we have the if-else selection structure, we are going to perform an action if the condition is true, and if it gets false, we have to perform a different action. In the switch selection structure, this is a little bit more advanced, in which we have different options of doing certain things. We have different actions, and we will be going to select that action. It will be depending on the value of the integer expression, that if we get this value, this type of action would be selected out of many actions. C++ if statement. An if statement consists of a Boolean expression followed by one or more statements. So as we are going to check the condition of the expression, and then we are deciding whether we have to execute the statements or not. So simply, we have the if keyword, which is specifically to execute this if selection structure. We have to use this if keyword, and after that, but as we are going to check the condition, we must have a Boolean expression within that. And the result of that Boolean expression must be true or false. It means that the only thing we are expecting within if what we are going to check within the if is the Boolean expression, whether we are expecting only two results. Either it would be true or false. And how can we get this true or false? This can only be possible if we have a Boolean expression. Otherwise, we can't get it. Or maybe otherwise, we might have some integer value, which is the non-zero value. It can also be considered as a true value. And the zero value can be considered as a false value. Now come towards the syntax of if statement. We have to write this keyword if, and within the parentheses, we have to write that Boolean expression on the result of which we have to decide that whether we have to execute the following statements or not. Another very important thing to show the graphical representation of an algorithm or a portion of the algorithm, we have different shapes to different stages of an algorithm. You can see that we have an oval shape over here. It indicates start or the begin or an end of a program. Then we have a rectangle, and rectangular action symbols to indicate any type of action, including a calculation or an input-output operation. Then we have the diamond, and the diamond are conditional or decision symbols. It indicates a decision to be made. We also have this parallelogram, and these are for the input and output symbols. We have the arrows, and the arrows shows the flow of control, also called as flow line. So usually we have the sequential execution or linear flow of control in a program, but here we are now come to a little bit advanced version of the C++ program, in which we have included now some selection structure in which we are checking whether the condition is true or not. So here, when we talk about the flow chart, the if selection flow chart looks like this. We have the Boolean expression within this diamond shape. And on the basis of the result of this Boolean expression, whether it's going to be true or false, if it gets true, we have to perform certain action. Otherwise, we will move to the other part of the program. Now come towards the quick example of the C++ program in which we are using the if selection structure. This is simple. We have declared a variable a and assign a value of 10. After that, we are using if selection structure. If a, the value of a, in which currently we are having a value of 10, if a is less than 20. So look at this expression. This is a Boolean expression, and we are going to check some relationship in between these two numbers. A is a variable, but actually a is having some value within that. So we are checking whether this a value is less than 20 or not. So simply the result we would get would be true or false. So if it's true, what happens that the block of the statements that is followed by this if statement will be executed. So if it's true, this will be executed. Cout, it means that it's going to print whatever is within these double quotes. So it will print a is less than 20. And then if it's false, it will just simply skip this statement. After this, the remaining part of the program, which is the value of a, whatever the value of a is, currently we have the 10 value in a, would be displayed on the screen. So if the condition is true, both these statements will be executed, and we can see these statements on the screen. But if this statement get false, then we can only see this statement, only one statement on the screen. Logic operators in if. So why logic operators are so important? We use these type of logic and relational operators within the Boolean expression to check the relationship between the two operands. And at the result of that, if the relationship is true, we get the true result. And if it's wrong, then we get a false result. So the equal to is one of the logic operator in which let's suppose we are checking that x equal to 10, whether the value that x holds equal to 10. So it might be true or false. Next, not equal to. If x not equal to 10, so it also we will also get true or false at the end of this. Less than x less than 10. Greater than x greater than 10. The value x holds is greater than 10 or not. Less than equal to, if it's less than or it's equal to 10. Greater than or equal to 10. And then we also have some compound operators. So we can extend our this logic in which we had only, in the previous slide, we had only one logic, one relation that we are checking. But we can also extend this further by using the compound operators in which we have here the simple version in which we have used this compound operator. Here logic and have been used in between two different logical expressions, Boolean expression. So this Boolean expression will also result either in true or false. And the second Boolean expression will also result in true or false. So both the results will get AND together. And here we are just using the logic of AND. If one of the operand in AND is 0, the result would be 0. Otherwise, if both of the operands in AND is 1, in this case only we can get the true result. So if both the Boolean expression results in true, then in this case only we can get the whole expression as true, and in that case only we can execute the statements which is within the block of if structure. After that, we have also another popular logic gate or logic we have OR, in which the simple version, again we are checking two Boolean expression over here. Here x equal to 1, and if we are checking whether x equal to 1 or y equal to 2. So if one of the Boolean expression gets true, the overall result will be true. And this is what the logic of OR is actually. If one of the operand is 1, we can get result as 1. If we get 0 only in the case if both the operands have 0 values. Now come towards logic NOT. If x is a non-zero value, we can flip this result. If we have the 0 value in x, we can flip its result to 1. So actually, if x is 0, using the NOT gate, it would become 1. The condition would true, and we can execute the statement within the if block. If selection structure, we have the example, and here is a pseudocode. If the student's grade is greater than or equal to 60, we have to print passed. So here we are going to apply a condition on the student grade. We are checking that whether the student grade is greater than or equal to 60 or not. If this statement is true, then we have to print on the screen that passed, right? So it's just using the if selection structure. The corresponding C++ code for this pseudocode is how we will write within the proper, using the proper grammar rules of the C++ program, what is the proper syntax of writing this pseudocode within a C++ program is that we have to write this if keyword within the parentheses. Remember that we have to write this parenthesis, and within the parenthesis, we have to write that Boolean expression according to the problem that we have given. Here, the problem is that we have to apply the condition on the student grade. So we are going to check the student grade over here, whether the grade is greater or equal to 60 or not. So if it's true, then we have to print passed over here. Now, the corresponding flow chart of the pseudocode statement is that grade is greater than 60 or greater than or equal to 60. If it's true, we have to print passed. Otherwise, we will go to the remaining part of the program. Now, there is another C++ program. Here, what we are going to do is we are going to check the relationship between the two numbers. For that, as we are going to check the relationship between the two numbers, it's must that we have to declare two numbers within our program. Now, we are declaring this number, and we are declaring that both the numbers are of integer data type. So we have to specify this like that. But up till now, we don't have any. We didn't initialize these numbers. So for that purpose, what we want is that we want the user to enter these numbers, and then we will tell whether these numbers are equal, greater than, what is the relationship between these two numbers. So just we declared the number, and we declared that these numbers are of integer data type, and then we are prompting the user to enter two integers, and I will tell you the relationship that they satisfy. So using the cout, we prompt the user to enter the number, and using the cins, we are getting the value into this num1 and num2. So two numbers the user have to enter. First number will go into the variable num1, and the second number entered by the user will go into the variable num2. Now come towards the main if selection structures. Now we are going to check that if, again, you can see we have the parenthesis, num1 equal to num2. Okay, if this condition is true, if let's suppose the user enter 5 and 5, both the numbers are equal here in this case, then this statements will get true, and we can see on the screen like number 1, which are having the value 5. 5 is equal to 5. As you can see that num1 is out of the double quotes, it means the value contained within num1 would be displayed on the screen. Secondly, the second relationship, if it gets true or not, we don't know. It depends on the numbers that the user enter. So if num1 not equal to num2, then according to the relationship they hold, accordingly message will be displayed on the screen. Next, if num1 is less than num2, similarly we have the other conditions for each and every relation, and this totally depends on the user, what type of numbers he enters. So here is a sample of entering two numbers. Here the user enter first for num1 he enters 35, and for num2 he enters 30. So what did display? 35 is not equal to 30. This condition also true, so it would be displayed on the screen. 35 is greater than 30. It's also true. 35 is greater than or equal to 30. It's also true. So all those relationships that are true about these two numbers would be displayed on the screen. So another example, if the user enter, let's suppose 25 and 25. So what would display on the screen? 25 is equal to 25. 25 is less than or equal to 25. Yes, 25 is greater than or equal to 25. Okay, as both numbers are equal, so the main equality statement would be displayed on the screen, like 25 is equal to 25 and 25 is less than or equal to 25. In this case, equality gets true, and we have the or statement within that, less than or. So less than doesn't holds, but equality sign gets true. So it would, this must would be replaced. Similarly, the case for greater than or equal here, the equality sign would be true. So another execution of statements in which the user entered 10 and 20. In this case, again, 10 is not equal to 20 and 10 is less than 20. Okay, this is also right. 10 is less than or equal to 20. This is also correct. So here the input that the user entered was 10 and 20. Now come towards another version of the if selection structure, which is a little bit advanced as compared to simply if selection structure. Here we have the if else statements. Let's see what's inside that. And if statements can be followed by an optional else statement which executes when Boolean expression is false. So here the main thing is that if the condition gets false, what will happen after that? So here in the else block, we are going to write a different action that we have to perform if the condition gets false. So the syntax for this is that we have to write this if keyword within the parentheses. We have to write the Boolean expression. If it gets true, the statement will be executed. Else, other statement will be executed. So here is the flow chart. You can see that we have the Boolean expression, and this is must. At this Boolean expression, we will be getting either the true or a false. So if this Boolean expression true, we have to perform an action, a certain action. But if it gets false, we have to perform some other action. And then we will go to the remaining part of the program. Here is a simple example. We can see the if else both within the program. This is actually the same program, but we have extended it to the if else. So here a is holding a value of 100. If a less than 20, so if this condition is true, then we have to print that a is less than 20. Else, otherwise, we have to print a is not less than 20. So basically, all depends on the Boolean expression that if holds. If this condition true, this will execute, else this. And this thing ends. This is the if else block. The statements are only in this region. After this if else block, we have the statement like value of a is a. So this is the must statement. Whether this is executed or not, whether this is executed or not, there is no relation of this statement with these one. We are just going in a sequential manner, but within a sequential manner, we encountered some selection structures. After the end of this selection structure, we have this statement, and there is no relation with the above structure. It has to be executed. Single and compound statement. Now come towards single and compound statement. Here we have, if we are having the single statements, which is associated with if and else block. Like you can see that we have the if, and we are going to check a certain condition. After that, we have a statement over here. So it's just a single statement. We don't have to write any curly brackets over here. So if the condition true, this statement would be executed. Else, we have this statement which will be executed. But what if we have multiple statements? If we don't have a single statement, but we have the multiple statement, then we have to include those statements within these curly brackets to show that this is the block of statements. This is the block which is associated with this if. all these blocks will come within this block, and these statements are executed with if. And then if this condition gets false, a complete block will not be executed, else it will go to the else block. Similarly, if in the else block too we have the multiple statements, then we have to enclose those multiple statements within these curly brackets to show that this is the complete block associated with this else. So if condition true, all this block would be executed. Otherwise, else block would be executed. So the thing is that the bottom line is that if we have the single statement, there is no need to write curly brackets. But if we have the multiple statement, we have to enclose those multiple statements within these curly brackets. Now, example, if you talk about the zero code, if the student grade is greater than or equal to 60, then we have to print pass, else we have to print fail. So the corresponding C++ code is very simple. We have to write this keyword if within the parentheses. We have to check on the student's grade whether this is greater than or equal to 60. Then we have to print pass, else we have to print fail. This is simply a flow chart which showing that the condition is true, print pass, false, we have to print fail, and then we will continue with the remaining part of the program. Compound statements, set of statements within a pair of braces, also called a block. If grade greater than or equal to 60, print passed, else we have to print failed, you must take this course again. So if the condition is true, there is a single statement that we have to print. So there is no need to write the curly brackets over here. But in the else, you know that if we are going to print the failed, then we are also giving the message that you must take this course again. So we have to write these two statements within a block to emphasize that all the statements are associated with this else block. Without the braces, if we forget to write these braces, then what will happen that only, let's suppose if condition gets false, then a field will be displayed. And you must take this course again would be displayed on the screen. But what if the condition gets true, past will be displayed on the screen, and then again it will display you must take this course again, and that is not what we want. We don't want to display this message that you must take this course again after passing the course. This is incorrect. So we have to be very careful in this situation that what we want and which statements would be within a block and which statements would be out of the block. So the statements that are out of the block would be executed independent of the if-else statements. Now come towards another simple example. Here you can see that we have declared some variables over here. One thing, we have a constant double having the value of 98.6. We know that this is the normal temperature human can have. And then double, we have a variable temperature. Here we are going to ask the user to enter your temperature, and then whatever the value the user enter will go into the variable that we already declared, but we didn't initialize, as we want that the value should come from the user side. So when whatever he enters would go into this temperature variable. Now we are going to apply some conditions on the entered value of the temperature. So we are checking over here that if temperature greater than norm actually contains a normal human temperature. So it's going to print, "You are sick. Take rest and drink lots of fluids. Else, you have to display that you are perfectly fine." So this was just a simple example in which we are going to check the temperature of a human. If it's greater than normal, it means that he is sick, and otherwise, if not, then you're perfectly fine. Now, output, you can see that entered your temperature. The user entered 100, so it's greater than the normal temperature. What is displayed on the screen? "You are sick. Take rest. Drink lots of fluids." This is what was in the else block. Now come towards in which the situation in which the user entered 98. Then what will display on the screen? "You are perfectly fine." Another example of if and if else selection structure drawn in flowchart form. So it can also be happen that you have to write a C++ program by looking at the flowchart. So you must know what this flowchart shows. So when you look at the flowchart, you start from the start, and then you are asking the user to enter the part number and the price. Then we are going to apply conditions on the part number equal to 03. If it's true, then the price equal to price multiplied by 1.1. And then we have to display the price increase message. Otherwise, we will do nothing, but we will go to the remaining part of the program, in which what we are just displaying the part number and price, and then the program just ends at this point. As compared to this block, as compared to this flowchart, we have another flowchart in which we are using if-else selection structure, in which the situation is that we have started our program, entered the sales, and we are going to apply conditions on the sales, that if sales is greater than 1500, if it's true, then what will happen? Commission equal to 0.02 multiplied with sales. So something is going to be multiplied with the sales, and the commission is greater as compared to the situation where this condition gets false. So if it gets false, the commission equal to 0.01 multiplied with sales. And then after this execution, we can go to the remaining part of the program. So whether it's executed the true part or the false part, we will have to go to the remaining part of the program. And what is that? Display the condition. So whatever the condition we get, whether the condition true, the condition was on the sales is greater than 1500, we had a large commission, and if it gets false, we have a little bit less commission in that case. Now, how we can write the C++ program for this specific flowchart. So for the program 1, in which we were having the part number and the price. So for both these numbers, we are going to declare some variables, part number and price. The part number is just a whole number, integer number, so we declare is that in data type. Price can hold floating point numbers, so we declare it as float. Now we ask the user to enter part number, so he enters certain number. Whatever he enters will go into the part number. Why? We have used here the cin, which takes the input from the user. Again, we displaying that enter the price. So he will enter the price. So if part number equal to 2003, so this is the certain specific part number in which we have to increase the price, maybe some precious one. So price equal to price multiplied by 1.1. Then we have to display the price after that. So if the condition get false, in that case, we have to just show the price, whatever the price entered by the user. But this is the case when the part number is 203, then we have to increase the price and then we have to show the increased price on the screen. So this is the output of the program. We ask the user to enter the part number. So he enters 200. Then we ask the user to enter the price. He said 100. So as this is, as the part number is not 203, it's 200. So the price is 100. Whatever the user has entered, the price would be displayed on the screen. So the part number is not equal to 203 in this case. Another case in which the user entered 203 part number, in that case, the price is again 100, but the total price at the end would be increased price, as this is the part number that we were looking at. Now come towards the C++ code for the second program, in which we had seen both the if and the else statements. If the condition true, we have to perform certain action, else we have to perform some different action. In this case, we are going to declare two variables, sales and commission. Both are having the data type float. Then we ask the user to enter the sales. So he enters some value. That value entered by the user will go into the sales variable. So applying the condition on the sales, how we will apply the condition on sales? We just write that in the form of a Boolean expression within the parentheses of if. So if sales is greater than 1500, commission is equal to sales multiplied with 0.2. Else, commission equal to sales multiplied with 0.1. So if its sales is not greater than 1500, it would be simply get multiplied with 0.1. But if its sale is greater than 1500, it would be having a greater commission, right? And just at the end, we have to display the value of the commission. Output here, you can see that entered the sales, he entered 1500. The commission is 150. Sales is 1500. But when he enters 1600, which is greater than 1500, the commission is 320. If else structure can also be done using the ternary conditional operator. Very interesting. The many statements can be squeezed within a single statement having the ternary conditional operator, which consisting of this question mark and then full colon. It's only a ternary operator. So binary operators take two operands. The unary operator take one operand, and this ternary operator take three operands. That's why called ternary operator. And we have this ternary conditional operator having this question mark and full colon. So three arguments, how it's going to work. We have certain conditions as we are applying it in if else selection structure. Condition is must. If the condition is value is true, then this statement would be executed, which is followed by this condition. Otherwise, this statement would be executed, which is almost the third one. Example, you can see that we are going to output something on the screen, but it's depending on some condition. And what is the condition over here? The condition is here grade greater than or equal to 60. We have a question mark. We have a question in our mind whether grade is greater than or equal to 60 or not. So if it's true, then if it's true, what will happen? The statement which is followed by this question mark would be executed. So past would be displayed on the screen. Past would be, why it's displayed, we are using cout over here, and this would be executed. Past will be shown on the screen. Otherwise, full colon, and after full colon, whatever we have would be displayed on the screen. So this is must. Here is the question mark. We are applying some condition on this statement. If it's true, this would be executed. Full colon and this one. The value in the conditional can be actions to execute. For example, we have this thing like grade is greater than 60. So here, what's going on? We have just write C out of this ternary out of this statement where we are using ternary conditional operator. But we can embed this C out within this expression. Like we are just applying the condition. We are checking whether the grade is greater than or equal to 60 or not, and then we are printing passed. Else we are printing failed. So in previous example, we have just written over here at one time, but we can also write C out individually to each of the statement.